Hello and welcome to another video for the Hoylake Computer Club. This is Tom at the club. Today we're going to do some more Python, but I thought we'd kind of mix it up a bit. We'll take some of the things that we've learned, like iterations and stuff. We'll kind of learn a new way of looping over things and try and solve a problem while we're doing so. We'll utilize kind of some slicing, some other stuff which are kind of list ways of doing things, but let's give it a go. We're going to try and solve the Fibonacci sequence. So we're going to look at different aspects of that. So first I'm going to open a new file, fib1.py. So let's think about this. So the Fibonacci sequence is a sequence of numbers, I believe originally used for mapping out the prediction of the mating sort of habits of rabbits to see how their population would grow. It has a lot of analogies within certain sequences, and it has a pattern which seems to keep repeating in nature. Now the premise of it is, the algorithm is, the Fibonacci number of n is equal to the previous two fibs. Yeah. Now this may be a little bit ambiguous, but let's dive into that as I think. So if we were to turn it into like an algorithm, we could have like fib of n, yeah, is equal to fib of n minus 1 plus fib of n minus 2. So it's the simplest sort of concept of what we want to get. So what that really means is, let's say we start at 0, the 0th Fibonacci sequence number, then the second one being 1. So now we do 0 plus 1 is equal to 1. 1 plus 1 is equal to 2. 2 plus 1 is equal to 3. 3 plus 2 is equal to 5. 5 plus 3 is equal to 8. So we can kind of work it out manually ourselves. 5 plus 8, and so on and so forth. Now, here's where it gets interesting. I mean, that's 13. But, so we need a programmatic way of doing this. So let's imagine it was a list. We could look at this list and go, okay, I need to look at an index of this index. So this index, where I take this plus this, and it becomes this item. If I'm at here, take this plus this, and it becomes this item. So we could kind of programmatically do that. Another interesting one would be what we call recursion, but that's a bit more of an advanced topic, and it's not very useful other than just to show recursion in this situation. So I'm going to make a new function, call it fib_n or something, passing in some sort of number, and I want it to do something. I want it to do fib_n of n is what we're doing, yeah? So we want that to be equal to, so we want our output to be equal to, we could do, okay, this is recursion. Our output is going to be equal to something. We could just return that. Let's return fib_n at n minus 1 plus fib_n at n minus 2. So that would technically be the algorithm. That we've solved the problem. The downside to this is it gets very, very memory intensive. It's calling that function over and over and over again. Every time you call that function once, it's calling it twice. So for every one of those twice, it's calling that twice and that twice, and it just creates this mass amount of calls. So the higher that Fibonacci n number gets, the slower this is going to be, and the more memory intensive, in which case it's probably going to crash. So let's define, well, let's not define, let's just run it. Fib_n at 4. 4 is not so bad, it'll probably work fine. So let's try that. So what we want to do is we want to run Python. What we've got, maximum, it's already gone more than 1,000 recursive calls just to get the fourth Fibonacci sequence number. How crazy is that? And you know why that is? We've got no way of stopping it. So 4 would not cause maximum recursion depth because it's just recursed more than 996 times. So what's the problem? Let's take a look. So if we look at this, it's going to literally carry on forever. There's no end. So what we need in a recursive function, we need some sort of thing like saying if n is, let's say, less than 2, yeah, return, let's think, 0, 1, 2, yeah, return n, let's say, okay? So let's take a look at this. That's great. So now we need to actually print this data out, okay, so it doesn't crash. So let's say fib equals this, and we'll print fib 3, the fourth Fibonacci sequence number. So let's look at it manually again. 0, 1, 1, 2, 3. The 0th Fibonacci number is 0. The first Fibonacci number is 1. The second is 1. Third is 2. The fourth is 3. How cool is that? We actually have a Fibonacci sequence. So we're able to actually do the fourth one. If you'll notice, if it goes too big, then it's going to kind of have recursion issues. So we can edit this and let's try and break it a bit. Let's say we want to go to the 20th. Can we get that? Oh, what did I do there? Did I manage to hit? Wow, that was supposed to be 20. I don't know how I managed to do that. Let's try that again. Ah boy, I'll just print it. Print fib n of 20. It got it, it didn't break. Okay, that's cool, so we can get the 20th one. How far can we go? Let's say we want the 50th one. Can we get there? Or is it going to break? It's taking a while. It's got to go do a load of calls. Now, I'm going to say it's probably going to crash. This may have been it crashing. Yeah, it's too big for it. It's like it doesn't know what it wants to do. It's just sticking there. So I'm going to Control-C that. So it's kind of like just really too much for it to get to the 50th one. So, how can we make this better? So let's take a look at it. So we've got it doing a recursive sort of thing, which is bashing the memory like crazy. So it's just really, really messing with the thing. So we don't necessarily want to do that, right? So let's comment that out. Let's think of another way of approaching this. Remember when I was doing it manually with this list? 0, 1, 1, 2, 3, and so on. How about we try to generate this list programmatically? We know that we can start with a 0 and 1 as our first two Fibonacci sequence numbers. So we can actually make our def fib list or something, taking in n. So let's think about this. We need an actual output list like fibs equals 0 and 1 to start with. So now we know we've got the 0th and the first Fibonacci sequence, right? So we want to do something to this fibs. So what we're saying is basically, let's try to get and generate a list up to the nth Fibonacci number. build this list. So what we can do is we can use a loop called a while loop. While a condition is true, keep looping. It's kind of like the for loop, but we're just giving it that. While a condition is true, keep looping. So to do this, we're going to say while the length of fibs is less than or equal to n, keep looping. And then all we need to do is we need to say the fibs dot append to add something to our list. Now we need to think about it. We need the current index, which is the one that we're working on, -1, and the current index -2. We can actually index into the end of a list with a negative value. So -1 is actually the end of the list. -2 is the second from end of list. And that's exactly what we want. We need those two values and add them together. So to do that, we can just say fibs at -1, which will give us the end of the list, plus fibs at -2, which will give us the second to end of list. And then append that value, which will be 1, to the list. Then the next iteration, you've got the -1 will be a 1, -2 will be a 1, so you add those together and you end up with a 2, and so on. So programmatically we can actually do that sequence that we did manually. And then at the end we could just return fibs for now. Okay, that's just going to give us a list. It's not going to be like Fibonacci sequence at n, but that's a good start. So we'll now print fib list, giving it 50. Remember that 50 didn't quite work at all, and it was taking ages. It was just sort of crashing. So let's try our new one. Okay. Oh look, almost instant. We now have the Fibonacci sequence up to the 50th Fibonacci sequence number. That's a lot faster and a lot more convenient. Now let's try and do a fairly large number. Let's turn it into a 500 instead of a 50. Let's see how it copes with it. Oh look, still almost instant. So we can do a fairly large Fibonacci sequence number. Now, let's try to make it now so that we can utilize this to gain fib at n. So let's edit this again one more time. So we'll call this one fib at n, just to be different. So insert def fib at n, passing it n. So now what we want to do is we kind of want to get that list first. So we'll say our list, let's say our fibs list is equal to fib list passing in n. Okay. Now all we need is we need the last item in that fibs list. Now you remember how to get the last item. The last item is -1. So we can say return fibs list at index of -1. So now if we don't print the fibs list at 500, let's do the fibs at, oh sorry, fib at n 500. Let's see if it gives us the right thing. So bear in mind this big number here, where is it? The last number in that list, it's 1394 something with 25 on the end. It's a massive number. Let's see if it gives us that. Whoops, didn't mean to zoom into that. 1394 with 25 on it. That's the same number. So we now can do a much more performant way of getting the Fibonacci number at a specific point. Let's just see where it breaks. Let's see if we can get like the 5,000th Fibonacci. This is probably going to break, but let's give it a go and see. Okay, it didn't break. This big massive number here that we have to scroll to read, I've got a feeling that's going to be accurate. The main reason is because it's like a 128-bit number, I believe, is available in Python. So you can store mass numbers. It may get less and less accurate as you get bigger and bigger, but in general, that should be fine for any just contrived test or code challenge. If somebody said, hey, can you write a Fibonacci sequence, fib at n sort of program, then your answer should be yes. And then you should be saying, well, how performant do you need it? And sort of what sort of size do you want to go up to? So that's it. So we now have our final form, fib at n, which utilizes our fib list functionality to gain a list of these Fibonacci sequence numbers, and then it just returns the end one. Hope you enjoyed this. If you did, give us a thumbs up. And if you want to see more content, do feel free to let us know of what sort of content you'd like to see. And also, if you want to keep up to date with the releases, what we're doing, feel free to subscribe and hit that bell icon for notifications. Thanks a lot for watching, everyone, and have a good day.